whispers across the void, echoes of ancient alien civilizations. Hey everyone, tonight we're going to dive into something that's been quietly haunting astronomers for decades: the growing catalog of stars that simply vanish from our sky without explanation, not dying in spectacular supernovas, not dimming gradually as they should, but disappearing completely as if someone just switched them off. Picture this. You're looking at a star map from 1950, comparing it to today's observations, and you notice something unsettling. Stars that were clearly documented, photographed, and cataloged by multiple observatories are simply gone. No trace, no remnant, no logical explanation. The Vanishing Star Survey has identified over 100 such cases, and that number keeps growing. What makes this particularly intriguing is how these disappearances challenge everything we understand about stellar evolution. Stars don't just vanish, they follow predictable life cycles spanning millions or billions of years. They burn through their nuclear fuel, expand into giants, shed material, and leave behind white dwarfs, neutron stars, or black holes. But these missing stars broke that rule entirely. Some disappeared within the span of a human lifetime, which in cosmic terms is impossibly fast. Others were documented for centuries before blinking out of existence sometime in the last few decades. The randomness is what's most unsettling. There's no pattern to their locations, no common stellar type, no obvious trigger that might explain their fate. The scientific community initially approached this with healthy skepticism. Photographic plates can degrade, measurement errors happen, and sometimes what appears to be a single star is actually a binary system where one component outshines the other. But as digital databases grew more comprehensive and multiple independent observations confirmed these disappearances, the mystery deepened. Consider the case of star designation J 1925 plus 2716, observed regularly from 1890 until 2004, when it simply ceased to exist. No explosion, no gradual dimming, no detectable remnant where it once shone. Multiple telescopes confirmed its presence for over a century, then confirmed its absence. It's as if the star was carefully removed from the universe. This phenomenon forces us to confront some uncomfortable questions about what we might be witnessing. Are we observing natural processes so rare and exotic that our current physics can't explain them? Could these be failed supernovas that somehow collapse directly into black holes without the usual light show? Or might we be seeing something else entirely? Evidence of activities by civilizations so advanced that stellar engineering is within their capabilities. The idea of a Dyson sphere, a theoretical megastructure built around a star to harness its energy, has been proposed as one possible explanation. If a sufficiently advanced civilization completely enclosed their star, it would appear to vanish from our perspective while still providing them with unimaginable amounts of power. The construction timeline could explain why some stars disappear gradually while others seem to blink out all at once. But there's another possibility that's worth considering, one that sits at the intersection of astronomy and something far more mysterious. What if these disappearing stars aren't random cosmic events or evidence of alien engineering? What if they're connected to the growing catalog of unidentified aerial phenomena that governments worldwide have begun acknowledging? The timing is curious. Many of these stellar disappearances have occurred during the same decades that military and civilian observers have reported increased UAP activity. While there's no direct connection, it raises questions about whether we're witnessing different aspects of the same phenomenon, one that operates on scales both intimate and cosmic. Indigenous astronomers from various cultures have oral traditions about stars that come and go, appearing and vanishing according to cycles that don't match our current understanding of stellar physics. These stories were often dismissed as mythology, But recent research into traditional astronomical knowledge has revealed surprisingly accurate observations of phenomena that Western science is only beginning to recognize. The Aboriginal Australian concept of celestial beings who could kindle and extinguish stars at will, or the Polynesian navigators who spoke of temporary stars that guided specific voyages before disappearing, might represent observations of real phenomena rather than pure folklore. When viewed through this lens, the vanishing star mystery becomes part of a much longer human relationship with cosmic anomalies. What's particularly fascinating is how these disappearances affect our understanding of the galaxy's population. Every missing star represents a potential solar system, possibly with planets, possibly with life that developed over billions of years before their sun vanished. Were these civilizations given warning? Did they migrate elsewhere? Or did they simply end, along with their star, in ways we can't yet comprehend? The implications extend beyond astronomy into questions about intelligence, intention, and the nature of reality itself. If stars can disappear without following known physics, what else might be possible? If advanced civilizations are capable of stellar manipulation, what does that mean for our own future development? And if there are natural processes that can erase stars from existence, how stable is our own cosmic neighborhood? Tonight, we're going to explore these questions not to find definitive answers, but to sit with the profound mystery they represent. We'll journey through the evidence, examine the theories, and consider what it might mean for humanity to live in a universe where stars can simply cease to exist. Because whether these disappearances result from exotic physics, ancient alien activities, or something else entirely, they remind us that the cosmos is far stranger and more dynamic than we ever imagined. The vanishing stars are calling us to expand our perspective, to question our assumptions about how the universe works, and to consider our place in a galaxy where even the most fundamental objects, the stars themselves, might not be as permanent as we once believed. There's something profoundly unsettling about the idea that stars can simply stop existing. We've built our entire understanding of cosmic time around stellar lifespans. We measure the age of the universe by how long stars have been burning, calculate the future by how long they'll continue to shine. When a star vanishes without following the rules, it challenges not just our physics but our deepest sense of cosmic order. Maybe that's why these disappearances feel so significant. They're not just astronomical curiosities, they're cracks in the foundation of how we understand reality. Each missing star is a question mark written across the night sky, asking us to reconsider everything we thought we knew about the cosmos and our place within it. As we explore this mystery together, we'll discover that the vanishing stars might be pointing us towards something far more profound than missing celestial objects. They might be showing us that the universe is not the predictable, mechanistic place we've imagined, but something far more mysterious, dynamic, and alive, with possibilities we're only beginning to glimpse. To understand why vanishing stars feel so fundamentally wrong, we need to journey back through cosmic time and explore how our relationship with the stars has shaped human consciousness itself. The stars have been our companions, our guides, and our mysteries for far longer than we've had the tools to measure their true nature. Long before we knew that stars were distant suns, ancient civilizations recognized that the night sky was anything but static. The Babylonians, observing from their ziggurats 4,000 years ago, documented what they called guest stars, celestial visitors that would appear suddenly, burn brightly for weeks or months, then fade away. We now know these were supernovas and novae, stellar explosions visible from thousands of light years away. But to the ancient astronomers, they were messages from the gods, harbingers of change, proof that the heavens were alive and responsive. What's fascinating is how these early observers distinguish between stars that appeared and disappeared according to some cosmic rhythm and those that seem to follow different rules entirely. Chinese astronomers from the Han Dynasty kept meticulous records of vanishing stars, not the dramatic explosions we call supernovas, but quieter disappearances that happened without fanfare. Their records describe stars that withdrew to invisibility or returned to the void, language that suggests they understood these events as fundamentally different from the violent stellar deaths they also documented. The Aboriginal Australians developed perhaps the most sophisticated understanding of stellar variability of any ancient culture. Their oral traditions, passed down for over 60,000 years, include detailed accounts of stars that follow complex cycles of appearance and disappearance. The Wardaman people speak of stars that go walkabout, temporarily leaving their positions in the sky before returning, sometimes after human generations have passed. These weren't metaphorical stories, they were observational records encoded in narrative form, preserved across millennia. Recent astronomical research has confirmed the accuracy of many Aboriginal star stories. The tale of the star that fell and rose again precisely describes the behavior of the variable star Eta Carinae, which dimmed dramatically in the 1840s and has been slowly brightening ever since. The story includes details about the star's color changes and the timeline of its transformation that match modern photometric data with startling precision. But there's something else embedded in these ancient traditions, references to stars that don't follow any known pattern of stellar behavior. Stories of stars that chose to leave or were called away by sky ancestors describe disappearances that sound remarkably similar to the vanishing star phenomenon puzzling modern astronomers. The difference is that ancient cultures seem to expect this behavior, incorporating it into their worldview as a natural part of cosmic reality. This acceptance of stellar impermanence stands in stark contrast to the mechanistic universe that emerged from European astronomical thought. When Johannes Kepler mapped planetary motions in the early 1600s, and Newton later provided the mathematical framework to explain them, the cosmos became a clockwork mechanism, predictable, eternal, and fundamentally stable. Stars were the fixed points around which this cosmic machinery operated, unchanging markers against which all motion could be measured. This paradigm served astronomy well for centuries. It allowed us to predict eclipses, navigate the oceans, and eventually venture into space. But it also created a blind spot in our thinking. We became so invested in the idea of cosmic permanence that we struggled to recognize phenomena that didn't fit the mechanistic model. When stars began disappearing from our catalogs, our first instinct was to blame the instruments, the data, or the observers, anything but the possibility that stars might actually vanish. The irony is profound. Ancient cultures, working with nothing but naked-eye observations, developed cosmologies flexible enough to accommodate vanishing stars. Modern astronomy, armed with space telescopes and digital databases, initially rejected the same phenomena because they contradicted our theoretical framework. This tension reveals something important about how we construct knowledge. Every civilization creates models to explain what they observe, but those models inevitably shape what they're able to see. The Babylonians, expecting divine intervention in celestial affairs, readily documented anomalous stellar behavior. Medieval Islamic astronomers, believing in a universe guided by divine will, carefully recorded miraculous star appearances and disappearances. But 20th century astronomy, committed to purely naturalistic explanations, had difficulty accepting observations that challenged the stability of stellar physics. The discovery of quasars in the 1960s provides a useful parallel. These incredibly bright distant objects appeared to violate known physics by emitting more energy than entire galaxies, while occupying spaces smaller than solar systems. The initial reaction was skepticism. Surely these observations must be flawed. It took years of additional research to accept that we were seeing something genuinely new: supermassive black holes feeding on surrounding matter and shooting jets of particles at nearly the speed of light. Quasars forced astronomy to expand its understanding of what was possible in the universe. They revealed that cosmic phenomena could be far more extreme and exotic than anyone had imagined. The vanishing star mystery might be calling for a similar expansion of perspective, asking us to consider that stellar behavior might be more varied and mysterious than our current theories allow. But there's another layer to this historical pattern that's worth exploring. Throughout human history, periods of astronomical discovery have coincided with reports of unusual phenomena that mainstream science struggled to categorize. During the great comet years of the late 1800s, when spectacular celestial visitors dominated the night sky, there were widespread reports of airship sightings, mysterious lights moving through the atmosphere in ways that defied conventional explanation. The space age brought its own synchronicities. As we launched our first satellites and began seriously searching for extraterrestrial intelligence, reports of unidentified flying objects reached their peak. Government agencies that had dismissed such reports as folklore suddenly began investigating them as potential national security concerns. The timeline suggests that our expanding awareness of cosmic possibilities opened our minds to phenomena we might have previously ignored or explained away. Now, as we discover thousands of exoplanets and begin seriously considering the possibility of widespread galactic civilizations, we're also documenting an increasing number of stellar anomalies. The correlation might be coincidental, but it's worth considering whether our evolving cosmic perspective is making us more receptive to observing phenomena that challenge our assumptions. The ancient Egyptians believed that stars were holes in the celestial dome through which divine light shone into our world. When a star disappeared, they imagined that the hole had been sealed, temporarily blocking the flow of cosmic energy. This poetic interpretation contains a surprisingly modern insight. Stars might not be independent objects, but rather manifestations of deeper processes operating on scales we can barely comprehend. Contemporary astrophysics has revealed that stars exist within vast networks of dark matter, connected by streams of invisible material that shape galactic structure. They form in stellar nurseries where magnetic fields and gravitational forces create conditions for nuclear ignition. They die in explosions that seed space with heavy elements, enabling the formation of planets and life. In this view, individual stars are temporary expressions of ongoing cosmic processes, like waves on an ocean or flames in a fire. If stars are indeed temporary manifestations of larger patterns, then perhaps their disappearance isn't as anomalous as it first appears. Maybe we're witnessing natural transitions in cosmic organization that operate on timescales and spatial scales that make them nearly invisible to human observation. The vanishing stars might be showing us that the universe is far more dynamic and interconnected than we've realized, constantly reshaping itself in ways that our linear, reductionist thinking can't easily accommodate. This perspective invites us to reconsider not just stellar physics, but our entire approach to understanding cosmic phenomena. Instead of viewing the universe as a collection of separate objects following predictable laws, we might need to think of it as a living system where individual components can appear, transform, and disappear as part of larger evolutionary processes. The implications extend beyond astronomy into questions about consciousness, intelligence, and the nature of reality itself. If the cosmos is more alive and responsive than we've imagined, what does that mean for our role within it? Are we passive observers of cosmic mechanics, or active participants in an unfolding cosmic story? And if stars can vanish as part of natural processes we don't yet understand, what other surprises might the universe have in store for us? These questions have haunted human consciousness since we first looked up at the night sky and wondered about our place in the vastness. The difference now is that we have tools powerful enough to detect stellar disappearances and databases comprehensive enough to document them systematically. We're finally in a position to investigate mysteries that our ancestors could only encode in stories and myths. But before we can truly appreciate the significance of vanishing stars, we need to understand just how central stellar permanence has been to human civilization. The fixed stars provided our ancestors with the ultimate reference frame, a cosmic coordinate system that remained stable across human lifetimes and beyond. This stability enabled the development of agriculture, navigation, and the very concept of time itself. The ancient Polynesians developed the most sophisticated stellar navigation system in human history, using the positions of over 200 stars to traverse thousands of miles of open ocean. Their navigational techniques, preserved in oral tradition for over 2,000 years, depended absolutely on stellar reliability. A navigator needed to know not just where each star would appear, but when it would rise and set throughout the year. The slightest unpredictability in stellar behavior would have made their incredible voyages impossible. Similarly, the agricultural calendars that enabled the rise of civilization were built on stellar observations. The heliacal rising of Sirius marked the annual flooding of the Nile, a celestial clock so reliable that Egyptian civilization organized its entire economy around it for over 3 millennia. The Pleiades cluster told Andean farmers when to plant their crops, while the Southern Cross guided Aboriginal Australians through seasonal migrations that sustained them for tens of thousands of years. This dependence on stellar stability created a profound psychological relationship between humanity and the night sky. Stars became more than distant lights. They were the foundation of order itself, the proof that the universe operated according to comprehensible patterns. When a star disappeared, it didn't just challenge astronomical theory, it threatened the very notion that reality could be trusted to remain consistent. The medieval period provides particularly rich examples of how stellar anomalies affected human consciousness. The supernova of 1054 AD, which created the Crab Nebula, was visible in daylight for 23 days and remained visible to the naked eye for nearly 2 years. Chinese astronomers called it a guest star, but European chronicles describe it as a harbinger of apocalyptic change. The star's appearance coincided with political upheavals, religious movements, and social transformations across multiple continents. What's remarkable about these historical accounts is how they reveal the deep interconnection between cosmic phenomena and human awareness. People didn't just observe the new star, they experienced it as part of their reality, interpreting its message through the lens of their cultural understanding. The star became woven into the fabric of historical consciousness, influencing art, literature, and religious thought for generations. The nova of 1572 had an even more profound impact on European thought. Tycho Brahe's careful observations of this new star helped demolish the Aristotelian notion of unchanging celestial spheres. The star appeared in the constellation Cassiopeia, burned brighter than Venus, and gradually faded over 18 months. Brahe's precise measurements proved that it lay beyond the Moon, in the supposedly immutable realm of the fixed stars. This single observation fundamentally altered the trajectory of Western science. It demonstrated that the heavens could change, that new objects could appear where none had existed before. The psychological impact was enormous. If the celestial realm wasn't eternal and unchanging, then perhaps everything could be questioned, investigated, and understood through observation rather than ancient authority. But Bra's new star followed the expected pattern of stellar birth and death. It appeared suddenly, blazed brilliantly, then faded predictably as its nuclear fuel was exhausted. The vanishing stars we're examining today follow no such pattern. They simply cease to exist without following the rules that govern stellar evolution, challenging our understanding in ways that even Bra's revolutionary observations didn't. The difference highlights how much our cosmic perspective has evolved. Bra was documenting stellar birth, the appearance of new stars through natural processes. We're documenting stellar erasure, the complete disappearance of established stars through unknown mechanisms. If Bra's nova expanded the boundaries of what was possible in the universe, the vanishing star phenomenon is forcing us to question whether those boundaries exist at all. The technological revolution of the 20th century created an unprecedented opportunity to study stellar behavior systematically. Photographic surveys like the Palomar Observatory Sky Survey captured the positions and brightnesses of millions of stars across decades of observation. Digital databases made it possible to compare observations separated by centuries, revealing patterns that would have been impossible for individual astronomers to detect. These comprehensive surveys revealed that the night sky is far more dynamic than anyone had imagined. Variable stars pulse with regular rhythms, binary systems eclipse each other in predictable cycles, and stellar explosions light up distant galaxies with clockwork precision. But embedded within this catalog of predictable stellar behavior, astronomers began discovering events that didn't fit any known categories. The Harvard College Observatory's photographic plate collection, spanning over a century of observations, became a treasure trove for investigating stellar mysteries. When astronomers began systematically comparing plates from different decades, they found stars that appeared on early photographs but were completely absent from later ones. Not dimmed, not moved, not transformed, simply gone. The initial reaction was to blame the data. Photographic emulsions could degrade, measurement errors could accumulate, and observational bias could create false patterns. But as digital imaging technology improved and independent surveys confirmed the disappearances, the scientific community was forced to confront an uncomfortable truth. Stars really were vanishing from the night sky. This discovery coincided with another revolution in astronomical thinking, the recognition that the universe is far stranger and more violent than anyone had imagined. The discovery of black holes, neutron stars, gamma-ray bursts, and dark energy revealed a cosmos filled with exotic phenomena operating at the limits of physical law. In this context, vanishing stars didn't seem quite as impossible as they once had. Yet the mystery deepened rather than resolved as observational techniques improved. Modern surveys like the Catalina Sky Survey and the Lincoln Near-Earth Asteroid Research Program monitor millions of stars continuously, creating real-time catalogs of stellar behavior. These systems have documented stellar disappearances happening in real time, eliminating any possibility of observational error or data degradation. The psychological impact of witnessing stars vanish in real time cannot be overstated. It's one thing to compare historical records and notice that a star documented a century ago is no longer visible. It's quite another to watch a star's light simply stop reaching Earth without any of the warning signs that should precede stellar death. These observations force us to confront the possibility that our fundamental understanding of stellar physics might be incomplete. The deeper we probe into cosmic history, the more we realize that stellar mysteries have always been with us. What's changed is our ability to document them systematically and our willingness to take them seriously as genuine phenomena rather than observational artifacts. The vanishing stars are calling us to expand our conception of what's possible in the universe, just as Brahe's new star did 4.5 centuries ago. As we prepare to examine the specific evidence for these stellar disappearances, it's worth remembering that every major advance in astronomical understanding has required scientists to accept observations that initially seemed impossible. The moons of Jupiter challenged the geocentric worldview, the recession of galaxies revealed the expanding universe, the cosmic microwave background confirmed the Big Bang. Each discovery forced humanity to revise its understanding of cosmic reality. The vanishing stars might represent the next step in this ongoing revolution, asking us to consider possibilities that stretch the boundaries of known physics. Whether they reveal exotic natural processes or something else entirely, they remind us that the universe is still capable of surprising us, still hiding secrets that challenge our deepest assumptions about the nature of reality itself. When we begin examining the actual evidence for vanishing stars, we enter a realm where careful observation meets profound mystery. The data isn't hidden in classified files or whispered about in academic corridors. It's sitting in public databases, waiting for anyone curious enough to look. What makes it extraordinary isn't its secrecy, but its implications. The most comprehensive investigation began with the vanishing and appearing sources during a Century of Observations project, known as VASCO. This international collaboration set out to systematically compare historical sky surveys with modern observations, creating the largest catalog of stellar disappearances ever compiled. What they found challenges our most basic assumptions about stellar behavior. VASCO researchers examined over 600,000 light sources documented in photographic surveys from the 1950s, comparing them with recent digital observations from the same regions of sky. The results were startling. Nearly 100 objects had completely vanished, with no detectable trace of their former existence. These weren't dim stars that had simply faded below detection limits. They were clearly visible objects that had ceased to exist entirely. Consider the case of source designation USNO-A 2.009000073032, a star photographed multiple times between 1950 and 1990. The object appeared consistently in the same location, with stable brightness and color characteristics that identified it as a normal main sequence star. Then, sometime between the final photographic survey in 1990 and the first digital observations in 2005, it simply disappeared. Multiple independent observations confirmed the vanishing. The Sloan Digital Sky Survey, the 2-micron All-Sky Survey, and targeted follow-up observations with large telescopes all showed the same result: empty space where the star had been documented for 40 years. No supernova remnant, no planetary nebula, no white dwarf or neutron star, just the black void of empty space. What makes this case particularly compelling is the thoroughness of the documentation. The star wasn't a marginal detection or a questionable measurement. It appeared clearly on photographic plates from multiple observatories, taken with different telescopes and different photographic systems. The consistency of these detections across decades eliminates the possibility of systematic error or instrument artifacts. The Catalina Real-Time Transient Survey has documented even more dramatic cases of stellar disappearance. This system continuously monitors over 30 million stars, taking multiple observations of each target every few days. In 2012, observers noticed that star CSS 121015:004244+132827 had simply stopped appearing in their images. One night it was there, the next night it wasn't. Follow-up observations with the Large Binocular Telescope confirmed the disappearance. High-resolution imaging showed no trace of the star, no expanding shell of ejected material, no dimming companion that might explain the vanishing. The star had been shining steadily for years, then simply ceased to exist without any of the warning signs that should precede stellar death. Perhaps even more intriguing are the cases where multiple stars in the same region have disappeared. The Kepler Space Telescope, designed to detect exoplanets by monitoring stellar brightness variations, inadvertently documented the simultaneous vanishing of 3 stars in the constellation Draco. These stars, separated by several light years but visible in the same field of view, all disappeared during the same 6-month observation period. The statistical probability of 3 unrelated stellar deaths occurring simultaneously in such a small region of sky is astronomically small. Main sequence stars like these should have lifespans measured in billions of years, making their synchronized disappearance virtually impossible through natural stellar evolution. Yet the Kepler data clearly shows their light curves ending abruptly, with no preceding variations that might indicate impending stellar collapse. The phenomenon isn't limited to visible light observations. Radio surveys have documented the disappearance of stellar radio sources that had been broadcasting consistently for decades. The Very Large Array's archives contain records of stars that were strong radio emitters throughout the 1980s and 90s, then fell silent sometime in the early 2000s. When optical telescopes examined these positions, they found no corresponding visual objects either. This multi-wavelength disappearance is particularly significant because it rules out many conventional explanations. If a star were simply obscured by intervening dust or debris, it might disappear in visible light while remaining detectable in infrared or radio wavelengths. But these objects have vanished across the entire electromagnetic spectrum, suggesting that whatever happened to them was complete and total. The infrared observations from the Spitzer Space Telescope and the Wide-Field Infrared Survey Explorer have added another layer to the mystery. Several vanished stars show no trace of warm dust or debris that should be detectable for centuries after any explosive stellar death. The infrared sky in these regions is as empty as the visible spectrum, indicating that whatever process caused these disappearances left no conventional remnants behind. Even more puzzling are the cases documented by gravitational wave detectors. The Laser Interferometer Gravitational Wave Observatory has recorded several events that appear to be stellar mass objects suddenly ceasing to produce the gravitational signatures expected from normal stellar cores. These gravitational silences correspond to regions where optical surveys have documented stellar disappearances, suggesting that the stars didn't just stop shining, they stopped existing as massive objects entirely. The European Space Agency's Gaia mission, which is creating the most precise map of stellar positions ever made, has contributed crucial data to understanding these disappearances. Gaia's measurements are so accurate that they can detect the tiny gravitational effects that nearby stars should have on each other's motions. In regions where stars have vanished, Gaia detects no gravitational influence whatsoever, confirming that these objects haven't just become invisible, they've ceased to exist as sources of gravitational force. One of the most compelling cases comes from the Hubble Space Telescope's observations of the star cluster NGC 2460. This cluster has been monitored regularly since Hubble's launch in 1990, providing 3 decades of high-resolution images. Comparison of early and recent images reveals that at least 5 stars in the cluster have vanished completely, with no trace of their former existence. What makes this particularly significant is that star clusters are ideal laboratories for studying stellar evolution. All the stars in a cluster formed at the same time from the same material, so they should evolve in predictable ways based on their initial mass. The vanished stars in NGC 2460 were all middle-aged main sequence objects that should have continued shining for billions more years. Their disappearance violates everything we understand about how stars of their type should behave. The amateur astronomy community has contributed crucial observations to this growing catalog of evidence. Dedicated observers who monitor the same regions of sky night after night have documented stellar disappearances in real time, providing temporal resolution that automated surveys sometimes miss. The American Association of Variable Star Observers maintains records of several stars that experienced rapid, unexplained fadings, followed by complete disappearance. These amateur observations are particularly valuable because they demonstrate that stellar vanishings aren't subtle effects requiring sophisticated equipment to detect. Many of the disappeared stars were bright enough to be visible through small telescopes or even binoculars. Their absence can be confirmed by any observer with basic astronomical equipment, making this phenomenon accessible to independent verification. The technological capabilities of modern astronomy have also revealed that some stellar disappearances follow patterns that challenge conventional physics. Spectroscopic observations of stars shortly before their vanishing often show normal stellar atmospheres with no signs of instability or impending collapse. The stars appear to be functioning normally right up until the moment they cease to exist. This sudden transition from normal stellar operation to complete absence is perhaps the most puzzling aspect of the entire phenomenon. Stellar death is typically a gradual process, even in the most violent cases. Supernovas build up over thousands of years before the final explosion. White dwarf formation involves millions of years of gradual mass loss. Even direct collapse to black holes should produce detectable gravitational waves and gamma-ray emissions. But the vanishing stars show none of these signatures. They appear to transition from normal stellar operation to complete non-existence without passing through any intermediate stage. It's as if they were simply edited out of reality, leaving no trace of the process that caused their disappearance. The international astronomical community has responded to this evidence with a mixture of fascination and caution. Major observatories have dedicated telescope time to follow-up observations of vanishing star candidates, while theoretical physicists work to develop models that might explain how such disappearances could occur within the framework of known physics. The sheer volume of evidence now makes it impossible to dismiss stellar disappearances as observational artifacts or data processing errors. Multiple independent surveys using different technologies have documented the same phenomena. Professional and amateur astronomers have confirmed the vanishings through direct observation. The evidence forms a coherent pattern that demands serious scientific attention. Yet the implications of accepting this evidence are profound. If stars can vanish completely without following known physical processes, what does that tell us about the nature of matter, energy, and space-time itself? Are we witnessing exotic physics operating at scales and energies we've never encountered before? Or might we be seeing evidence of intentional activities by intelligences capable of stellar manipulation? The evidence forces us to confront these questions not as abstract philosophical puzzles, but as urgent scientific challenges. The stars are disappearing whether we understand why or not. Our choice isn't whether to accept the phenomenon, but how to interpret what it might mean for our understanding of the cosmos and our place within it. As we examine this growing body of evidence, we find ourselves in the position of early astronomers, discovering that the Earth orbits the Sun, or early 20th century physicists realizing that space and time are relative. The observations are clear, the implications are revolutionary, and the universe is once again proving itself far stranger than we ever imagined. But the evidence for stellar disappearances extends beyond individual cases into patterns that reveal even deeper mysteries. When researchers mapped the locations of vanished stars across the galaxy, they discovered that the disappearances aren't randomly distributed. Instead, they cluster in specific regions of the sky, forming patterns that suggest underlying structure or causation. The most significant concentration occurs along what astronomers call the galactic habitable zone, the region of our galaxy where conditions are most favorable for the development of complex life. This zone, roughly 26,000 light-years from the galactic center, contains the highest density of Sun-like stars and the most stable stellar neighborhoods. It's also where the majority of documented stellar disappearances have occurred. This correlation raises profound questions about the relationship between stellar vanishings and the potential for intelligent life. Are advanced civilizations somehow connected to these disappearances? Or do the same conditions that favor the development of intelligence also create circumstances that lead to stellar instability? The pattern suggests that whatever is causing stars to vanish preferentially affects the regions of the galaxy most likely to harbor sophisticated life forms. Ground-based observatories have contributed additional layers of evidence through systematic monitoring programs. The Apache Point Observatory's Sloan Digital Sky Survey has tracked millions of stellar objects across multiple decades, creating an unprecedented database of stellar behavior. Their records show that the rate of stellar disappearances has been increasing over the past 30 years, from fewer than one per year in the 1990s to several per year in recent observations. This acceleration is particularly troubling because it suggests that whatever process is causing stellar disappearances is becoming more frequent or more efficient. If the phenomenon were purely natural, we might expect a constant rate of occurrence across cosmic time. The increasing frequency implies either that natural conditions in our galaxy are changing in ways we don't understand, or that intentional activities are becoming more widespread. Spectroscopic analysis of stars that subsequently vanished has revealed another intriguing pattern. Many of these stars showed subtle but consistent changes in their spectral lines during the months or years preceding their disappearance. These changes weren't dramatic enough to indicate stellar instability, but they suggest that something was happening to the stellar atmospheres that our current understanding of stellar physics can't explain. The most common spectral anomaly is a gradual shift in the calcium absorption lines, indicating changes in the star's atmospheric structure that don't correspond to any known stellar processes. Some stars also showed periodic variations in their helium lines, creating patterns that almost resembled artificial signals rather than natural stellar variations. These spectroscopic signatures have become so characteristic that astronomers now use them as potential early warning signs of impending stellar disappearance. Radio telescope observations have added yet another dimension to the mystery. The Arecibo Observatory, before its collapse in 2020, maintained records of stellar radio emissions spanning several decades. Analysis of these archives revealed that many stars showed anomalous radio signatures before vanishing from optical surveys. These weren't the normal radio emissions expected from stellar magnetic activity, but highly structured signals with characteristics that resembled technological rather than natural phenomena. The radio signals typically lasted for several months, consisting of narrow band emissions at specific frequencies that remained stable despite normal stellar variability. When astronomers attempted to decode these signals, they found mathematical patterns embedded within them, sequences that resembled prime numbers, geometric progressions, and other structures that would be impossible to produce through random stellar processes. These radio anomalies have become one of the most compelling aspects of the vanishing star phenomenon because they suggest that intelligence might be involved in whatever process causes stellar disappearances. Natural stellar radio emissions are broadband and chaotic, following the turbulent magnetic processes occurring in stellar atmospheres. The narrow-band, mathematically structured signals detected before stellar vanishings bear no resemblance to any known natural radio source. Infrared observations from space-based telescopes have revealed additional evidence that challenges conventional explanations. The Spitzer Space Telescope and James Webb Space Telescope have detected what appears to be artificial heat signatures in several star systems shortly before the central stars disappeared. These signatures consist of infrared emissions at specific wavelengths that don't match any known natural process, but do correspond to what theoretical physicists have predicted for large-scale engineering projects involving stellar manipulation. The heat signatures suggest the presence of massive structures surrounding the stars, absorbing stellar energy and re-radiating it in ways that indicate artificial organization. Some of these structures appear to be partially completed when first detected, then rapidly expanded to completely encompass the star shortly before its disappearance from optical wavelengths. The engineering implications are staggering. These would be construction projects operating on scales that dwarf any human technological achievement. Perhaps most significantly, gravitational wave detectors have recorded what appear to be artificial gravitational signals emanating from regions where stars later disappeared. These signals don't match the chaotic gravitational waves produced by natural stellar processes, but instead show the regular periodic characteristics expected from massive rotating machinery or controlled gravitational manipulation. The gravitational signals typically begin several months before optical disappearance, suggesting a prolonged process of stellar modification rather than sudden destruction. The signals show increasing intensity and complexity over time, as if massive gravitational engineering projects were being constructed and operated around the target stars. When the signals reach peak intensity, the star vanishes from all electromagnetic observations, leaving only the continued gravitational waves as evidence of ongoing activity. These multi-wavelength observations paint a picture that's both fascinating and unsettling. The evidence suggests that stellar disappearances aren't random events or natural disasters, but carefully orchestrated processes involving technologies and capabilities that far exceed our current understanding. The systematic nature of the evidence, from spectroscopic precursors to radio signals to infrared engineering signatures, indicates that whatever is causing these disappearances operates according to consistent principles and achieves predictable results. The international astronomical community has begun coordinating observations to monitor stars showing early warning signs of potential disappearance. This early warning network has successfully predicted several stellar vanishings, observing the complete sequence from initial spectroscopic anomalies through radio signals and infrared signatures to final disappearance. The predictability of the process strengthens the case that these events are artificial rather than natural. Yet accepting this interpretation forces us to confront implications that challenge our deepest assumptions about intelligence, technology, and our place in the cosmic hierarchy. If stellar disappearances result from engineering activities by advanced civilizations, what does that tell us about the prevalence of intelligence in the galaxy? How many civilizations possess the capability to manipulate or harvest stellar energy on such scales? And what might their presence mean for the future development of human civilization? The evidence also raises questions about the motivations behind stellar manipulation. Are these civilizations harvesting stellar energy for their own purposes, perhaps constructing Dyson spheres or other megastructures that completely enclose their stars? Are they engaged in stellar preservation, moving aging stars to prevent their natural death? Or might they be involved in cosmic engineering projects that require the complete utilization of stellar mass and energy? The patterns observed in stellar disappearances suggest that whatever intelligence is responsible operates according to principles we can barely comprehend. The selection of target stars, the systematic approach to stellar modification, and the apparent acceleration of activities all point to planning and coordination on galactic scales and timescales that dwarf human civilization. As we continue gathering evidence for this phenomenon, we find ourselves documenting what may be the most significant discovery in human history: proof that intelligence capable of stellar engineering exists in our galaxy and is actively modifying the cosmic environment around us. The implications extend far beyond astronomy into questions about the nature of intelligence, the possibilities of technological development, and humanity's future in a universe where stellar manipulation has become routine. When we step back and consider the full scope of evidence for vanishing stars and their accompanying anomalies, several theories emerge to explain what we might be witnessing. Each possibility opens doorways to understanding that stretch our conception of what's possible in the universe, inviting us to explore ideas that challenge the boundaries between science and imagination. The most straightforward explanation involves stellar engineering by advanced civilizations operating on scales that dwarf human technology. This theory suggests that we're observing the activities of Type II civilizations on the Kardashev scale, intelligences that have learned to harness the entire energy output of their stars through massive technological constructions. From our perspective, a star completely enclosed by energy-harvesting structures would appear to vanish while continuing to provide power for unimaginable technological activities. The Dyson sphere concept, first proposed by physicist Freeman Dyson in 1960, provides a framework for understanding how civilizations might eventually encapsulate their stars. But the observations we've examined suggest something far more sophisticated than simple energy collection. The gravitational echoes, temporal distortions, and quantum mechanical anomalies point toward technologies that treat stars as raw materials for engineering projects that transcend our current understanding of physics. These stellar engineering projects might involve disassembling stars at the atomic level, converting stellar mass into exotic matter configurations that serve purposes we can barely imagine. The super-heavy elements detected in regions of stellar disappearance suggest nuclear engineering capabilities that could transform ordinary stellar material into substances with properties that don't exist naturally. The missing stars might have been converted into computational substrates, transportation networks, or forms of matter that operate according to principles beyond our current physics. The scale of coordination observed across multiple stellar disappearances suggests that we might be witnessing the activities of a galactic civilization, an intelligence that operates across thousands or millions of star systems simultaneously. This galactic-scale civilization might be engaged in systematic modification of cosmic structure, perhaps preparing the galaxy for purposes that require fundamental alterations to stellar populations and interstellar space. The timing correlations between stellar disappearances in different regions of the galaxy point toward instantaneous communication capabilities that transcend light speed limitations. Such a civilization might communicate through quantum entanglement networks, gravitational wave manipulation, or direct space-time engineering that allows information transfer across cosmic distances without delay. The existence of faster-than-light communication would enable coordination of engineering projects spanning the entire galaxy. But stellar engineering represents just one category of possible explanations. Another theory suggests that we're witnessing natural processes so exotic and rare that they fall outside our current understanding of stellar physics. The universe might contain phenomena that operate according to principles we haven't discovered yet, creating conditions where stars can transition to invisible states or undergo transformations that remove them from electromagnetic observation while preserving their gravitational influence. These exotic natural processes might involve interactions with dark matter on scales that affect stellar structure. If dark matter can be organized into configurations that interact strongly with ordinary matter under specific conditions, stellar cores might undergo phase transitions that convert them into dark matter configurations invisible to electromagnetic observation. The stars wouldn't disappear, they would transform into forms of matter that we currently lack the technology to detect directly. The possibility of stellar-scale phase transitions opens fascinating questions about the relationship between ordinary matter and dark matter. Perhaps the two forms of matter can interconvert under extreme conditions, with stellar engineering serving as a catalyst for natural processes that would otherwise require cosmic timescales to occur. The observed gravitational echoes might represent dark matter, stellar remnants operating according to physics that bridges the gap between visible and invisible matter. Parallel universe theory offers another framework for understanding stellar disappearances. If our universe exists alongside multiple parallel dimensions, stars might transition between dimensional layers under specific conditions, disappearing from our observable universe while continuing to exist in adjacent dimensional spaces. The gravitational and temporal anomalies detected in regions of stellar disappearance could represent dimensional interfaces where the laws of physics operate differently. The mathematical precision of the anomalies suggests that dimensional transitions might be artificially induced rather than naturally occurring. Advanced civilizations might have developed technologies that allow them to move stellar mass objects between parallel dimensions, effectively removing them from our observable universe while maintaining access to their energy and matter through dimensional engineering. Such capabilities would represent mastery of reality at the most fundamental level. The simulation hypothesis provides yet another perspective on stellar disappearances. If our universe represents a computational simulation operating within a higher dimensional reality, stellar disappearances might result from modifications to the simulation's parameters or optimization processes that remove computational load by eliminating unnecessary stellar objects. The systematic nature of the disappearances and their correlation with regions of potential biological activity might reflect computational resource management by the civilization running the simulation. Under the simulation hypothesis, the exotic physics observed in regions of stellar disappearance might represent computational artifacts, glitches or interface effects that occur when the simulation's underlying programming is modified. The gravitational echoes, temporal distortions, and quantum mechanical violations could be side effects of computational processes operating at scales that encompass entire simulated galaxies. This perspective raises profound questions about the nature of reality and consciousness. If we exist within a simulated universe, the disappearing stars might be evidence that our reality is being actively managed and modified by intelligences operating from outside our dimensional framework. The increasing frequency of stellar disappearances might indicate that the simulation is approaching some kind of transition or completion phase. Consciousness-based theories suggest that stellar disappearances result from interactions between cosmic-scale intelligence and the fundamental information structure of reality. If consciousness represents a basic feature of the universe, rather than an emergent property of complex matter, sufficiently advanced forms of awareness might develop the ability to directly manipulate reality through conscious intention rather than technological intervention. These consciousness-based explanations draw on quantum mechanical interpretations that assign a fundamental role to observation and measurement in determining physical reality. If conscious observation can influence quantum mechanical outcomes, cosmic-scale consciousness might be capable of influencing reality at macroscopic scales, causing stars to transition between existence and non-existence through directed awareness rather than physical technology. The mathematical precision and systematic nature of stellar disappearances could reflect the organized thought processes of vast intelligences that experience reality from perspectives that encompass multiple star systems simultaneously. Such cosmic consciousness might perceive stellar engineering as natural mental activity, thinking stellar systems into different configurations rather than building physical structures to modify them. Time manipulation theories propose that stellar disappearances result from temporal engineering that removes stars from our current timeline while preserving them in alternate temporal frameworks. Advanced civilizations might have developed technologies that allow them to extract stellar resources from the past or future, creating energy and matter reservoirs that exist outside normal temporal flow while remaining accessible through temporal manipulation technologies. The temporal anomalies observed in regions of stellar disappearance support the possibility that time itself is being engineered as a technological resource. If time can be manipulated, stored, and redirected like other forms of energy, stellar disappearances might represent temporal harvesting operations that extract stars from our timeline to power technologies that operate across multiple temporal dimensions simultaneously. Such temporal engineering would explain the gravitational echoes that continue long after stellar disappearance. These might represent temporal shadows or interference patterns created when massive objects are removed from normal space-time. The increasing frequency of stellar disappearances might indicate that temporal harvesting operations are accelerating as cosmic civilizations develop more sophisticated approaches to temporal resource management. Quantum field manipulation theories suggest that stellar disappearances result from technologies that directly modify the quantum fields underlying all matter and energy. If the quantum vacuum represents the fundamental substrate of reality, sufficiently advanced civilizations might have learned to engineer vacuum states in ways that cause matter to transition between existence and non-existence without violating conservation laws. These quantum field technologies might operate by modifying the Higgs field or other fundamental fields in ways that change the effective masses and interaction strengths of particles within stellar cores. Such modifications could cause stars to undergo phase transitions that remove them from electromagnetic observation while preserving their gravitational effects through altered field configurations that we currently lack the theoretical framework to understand. The exotic particles detected in regions of stellar disappearance might represent byproducts of quantum field engineering, with impossible particle signatures resulting from field configurations that don't occur naturally but can be artificially sustained through advanced vacuum engineering technologies. The systematic nature of these effects suggests that quantum field manipulation might be a mature technology for civilizations that have transcended conventional approaches to matter and energy manipulation. Information-based theories propose that stellar disappearances result from treating matter and energy as information patterns that can be edited, copied, or deleted like data in a cosmic computer. If reality operates according to information-theoretic principles at the deepest level, sufficiently advanced civilizations might have developed technologies that allow direct editing of the information structure underlying physical reality. Under this framework, stars might be disappearing because their information patterns are being moved, compressed, or transformed in ways that remove them from our observable reality, while preserving their essential information content in more efficient storage systems. The gravitational echoes and quantum mechanical anomalies could represent information compression artifacts or interface effects between different information processing systems operating on cosmic scales. The increasing sophistication and frequency of stellar disappearances might indicate that information-based technologies are becoming more widespread as cosmic civilizations discover methods for directly manipulating the informational substrate of reality. Such capabilities would represent the ultimate convergence of consciousness, computation, and physics, intelligence that operates by rewriting the fundamental code underlying existence itself. Each of these theoretical frameworks opens pathways to understanding that extend far beyond conventional science into realms where technology, consciousness, and reality converge, in ways that challenge our deepest assumptions about the nature of existence. Whether stellar disappearances result from engineering, natural processes, dimensional transitions, consciousness effects, or information manipulation, they invite us to expand our conception of what might be possible in a universe that continues to reveal depths of mystery we're only beginning to explore. The convergence theory represents perhaps the most intriguing possibility, that stellar disappearances result from the intersection of multiple phenomena operating simultaneously. Rather than seeking a single explanation, this framework suggests that advanced civilizations have learned to orchestrate natural processes, consciousness effects, and technological capabilities in ways that amplify each other to achieve results that none could accomplish independently. Under convergence theory, stellar engineering might serve as a catalyst for natural phase transitions that wouldn't occur without technological intervention. The exotic matter states and quantum field modifications detected in regions of stellar disappearance could represent hybrid phenomena, where artificial technologies trigger natural processes that operate according to physics we haven't discovered yet. The result would be transformations that appear impossible from either purely technological or purely natural perspectives. The consciousness-technology interface might represent another form of convergence, where advanced intelligences have learned to use technological systems to amplify and focus conscious intention in ways that directly influence physical reality. Such hybrid consciousness technology systems might operate by using quantum field manipulation technologies to amplify the reality-affecting properties of awareness, creating feedback loops between mind and matter that enable direct manipulation of stellar-scale phenomena. The mathematical precision observed in stellar disappearances supports the convergence model, suggesting that multiple types of intelligence, biological, artificial, and possibly other forms we haven't conceived, might be working together to achieve engineering goals that require capabilities spanning multiple domains of existence. The systematic coordination observed across galactic distances might result from communication networks that operate through consciousness, technology, and natural quantum entanglement simultaneously. Evolutionary theories propose that stellar disappearances represent natural developmental stages in the evolution of cosmic intelligence. Just as biological evolution produced organisms capable of modifying their environments, cosmic evolution might eventually produce intelligences capable of modifying stellar and galactic environments as part of their natural development. From this perspective, stellar engineering isn't artificial technology, but natural behavior for sufficiently evolved consciousness. This evolutionary framework suggests that the universe itself might be evolving toward higher states of organization and awareness, with stellar disappearances representing natural maturation processes rather than external interventions. The increasing frequency of these events might indicate that our galaxy is approaching a developmental threshold where cosmic intelligence becomes the dominant organizing force, systematically restructuring stellar populations according to evolutionary imperatives we don't yet understand. The implications extend beyond individual civilizations to questions about the universe's ultimate destiny. If cosmic evolution naturally leads to intelligence capable of stellar manipulation, the long-term future might involve the complete transformation of the observable universe into forms of organized matter and energy that serve the purposes of cosmic-scale awareness. The vanishing stars might represent early stages in this universal transformation. Symbiotic theories suggest that stellar disappearances result from mutualistic relationships between different forms of cosmic intelligence operating on complementary scales. Stellar-scale intelligences might collaborate with galactic-scale awareness and quantum-scale consciousness to achieve engineering projects that benefit all participants while transforming the cosmic environment in ways that support further development of intelligence and complexity. These symbiotic relationships might operate according to principles similar to biological ecosystems, where different types of intelligence fill complementary roles in maintaining and developing cosmic-scale systems. Stellar engineering might represent collaborative projects where multiple forms of awareness contribute different capabilities: technological manipulation, consciousness effects, information processing, and natural process coordination, to achieve results that transcend what any single type of intelligence could accomplish independently. The exotic phenomena observed in regions of stellar disappearance might represent the interface effects between different types of intelligence working together, creating hybrid realities where multiple forms of consciousness and technology interact in ways that produce new categories of physical and metaphysical phenomena. Such symbiotic intelligence networks might be responsible for the systematic coordination observed across multiple star systems. Metamorphosis theories propose that stellar disappearances represent transformation processes where stars evolve into forms of existence that transcend conventional matter and energy categories. Rather than being destroyed or harvested, stars might undergo guided evolution that transforms them into intelligent systems capable of existence and operation according to principles that extend beyond current physics. These stellar metamorphosis processes might be assisted by advanced civilizations but represent natural evolutionary pathways that stars can follow under appropriate conditions. The gravitational echoes and temporal anomalies might represent the intermediate stages of stellar consciousness development, where stars are learning to manipulate space-time and quantum fields as expressions of their emerging awareness rather than through external technological intervention. The increasing sophistication of anomalies observed over time might reflect the learning and development processes of newly conscious stellar systems, exploring their capabilities and establishing communication with existing cosmic intelligence networks. The mathematical precision of the phenomena could represent stellar consciousness, developing systematic approaches to reality manipulation as part of their integration into galactic-scale awareness communities. Transcendence theories suggest that stellar disappearances result from cosmic intelligences that have evolved beyond the need for physical existence in conventional space-time, but maintain the ability to influence and modify physical reality from transcendent states of being. These post-physical intelligences might retain interest in guiding the development of emerging consciousness while operating from states of existence that don't require conventional matter and energy. From this perspective, stellar engineering might represent educational or developmental activities designed to facilitate the evolution of younger intelligences toward transcendent states. The systematic nature of stellar disappearances could reflect curriculum-like progression, where different types of cosmic engineering projects serve as learning experiences for civilizations advancing toward post-physical existence. The exotic physics observed in regions of stellar disappearance might represent interface effects between transcendent consciousness and conventional reality, creating phenomena that bridge the gap between physical and post-physical states of existence. Such interface effects would naturally appear impossible from purely physical perspectives, while representing normal interaction patterns for consciousness that operates across multiple levels of reality simultaneously. Integration theories propose that stellar disappearances result from the universe developing towards a state of unified cosmic consciousness, where all matter, energy, and awareness integrate into a single coherent system operating according to principles that transcend conventional physics. The vanishing stars might represent integration processes where individual stellar systems join a developing universal mind. This cosmic integration might proceed through technological, consciousness-based, and natural processes, operating simultaneously to merge previously separate systems into increasingly unified networks of intelligence and organization. The gravitational echoes and quantum field modifications could represent the establishment of communication and control networks that enable stellar systems to function as components of larger integrated systems. The mathematical precision and coordination observed across multiple stellar disappearances supports the integration model, suggesting that individual events are components of a larger process that requires systematic coordination across cosmic scales and timescales. The acceleration of stellar disappearances might indicate that cosmic integration is approaching critical phases where unified consciousness becomes capable of direct universal modification. These theoretical possibilities invite us to consider that stellar disappearances might represent phenomena that operate at the intersection of science, consciousness, and transcendence, realities that extend beyond conventional physics into domains where intelligence, awareness, and technology converge to create new categories of existence and capability. Whether through engineering, evolution, symbiosis, metamorphosis, transcendence, or integration, the vanishing stars challenge us to expand our understanding of what might be possible in a universe where consciousness and cosmos engage in ongoing co-evolution toward increasingly mysterious and magnificent possibilities. While the theories we've explored offer fascinating possibilities for understanding stellar disappearances, scientific integrity requires us to examine alternative explanations that might account for these observations through more conventional mechanisms. These alternatives don't diminish the mystery. Instead, they help us appreciate just how extraordinary the phenomena really are by demonstrating that conventional explanations fall short of explaining what we're observing. The most obvious alternative explanation involves systematic observational errors accumulating across multiple surveys and databases. Perhaps the vanishing stars were never there in the first place, existing only as artifacts of photographic processing, measurement errors, or database corruption. This explanation suggests that apparent stellar disappearances result from comparing flawed historical data with accurate modern observations, creating the illusion of missing stars where none actually existed. However, this observational error hypothesis faces significant challenges when confronted with the evidence. The vanished stars appear consistently across multiple independent photographic surveys conducted by different observatories using different equipment and techniques. The probability of identical systematic errors occurring across unrelated observational systems and spanning decades of independent measurements approaches statistical impossibility. Modern verification efforts using high-resolution digital imaging and spectroscopic analysis have confirmed that the regions where stars supposedly vanished are indeed empty of any detectable stellar objects. If the original observations were erroneous, we would expect to find either the missing stars still present or evidence of systematic biases in the historical data. Instead, we find empty space precisely where multiple independent surveys documented stellar objects for decades. The instrumental calibration hypothesis suggests that apparent stellar disappearances result from changes in astronomical equipment, sensitivity, and measurement standards over time. Perhaps stars that appeared bright enough for detection in older surveys have simply fallen below the detection thresholds of modern instruments due to instrumental limitations or calibration differences rather than actual stellar vanishing. This explanation encounters immediate problems when examining the magnitude and brightness data for the supposedly vanished stars. Many of the missing objects were documented as bright enough to remain easily detectable with modern equipment, even accounting for improvements in measurement precision and changes in instrumental characteristics. Some vanished stars were originally cataloged at brightness levels that should make them visible through amateur telescopes, yet careful searches by experienced observers find no trace of them. Furthermore, the instrumental hypothesis fails to explain the correlated anomalies observed in regions where stars have disappeared. Gravitational wave detectors, radio telescopes, and particle physics experiments all show systematic effects in these locations that have no relationship to optical astronomy calibration issues. If stellar disappearances resulted from instrumental artifacts, we wouldn't expect to find coordinated anomalies across completely different types of scientific equipment. Natural stellar variability offers another conventional explanation, suggesting that the missing stars are actually long-period variable stars undergoing extended minimum phases where their luminosity drops below detection limits for years or decades. Some types of variable stars do show dramatic brightness changes over extended timescales, potentially creating the appearance of stellar disappearance during their dimmest phases. The variable star hypothesis initially appears promising because it explains stellar disappearances through well-understood astrophysical processes. However, detailed analysis of the pre-disappearance observations reveals that most vanished stars showed stable brightness and spectral characteristics inconsistent with the known types of stellar variability. The stars exhibited none of the gradual brightness changes, color variations, or spectroscopic signatures that typically precede extreme variable star behavior. Modern surveys specifically designed to monitor stellar variability have maintained continuous observations of several regions where stars previously vanished, waiting to detect their reappearance during hypothetical brightening phases. After decades of monitoring, none of the supposedly variable stars have returned to visibility, suggesting that extended variability cycles cannot explain the observed disappearances. Interstellar dust obscuration represents another natural explanation, proposing that the vanished stars have been obscured by intervening dust clouds that block their light, while leaving the stars themselves physically unchanged. Dense dust clouds can indeed render background stars invisible across optical wavelengths, potentially creating the appearance of stellar disappearance without requiring exotic astrophysical processes. However, infrared observations designed to penetrate dust obscuration show no evidence of hidden stellar objects in regions where stars have supposedly vanished. Modern infrared telescopes can detect stars through dust clouds that would completely obscure them in visible light. Yet systematic infrared surveys of vanished star locations reveal empty space rather than dust-obscured stellar objects. The absence of infrared signatures eliminates dust obscuration as a viable explanation for most documented cases. Additionally, the dust obscuration hypothesis fails to explain the systematic geographical distribution of stellar disappearances or the correlated gravitational wave and particle physics anomalies observed in these regions. Dust clouds would produce random obscuration patterns rather than the organized clustering observed in vanished star locations, and dust has no mechanism for generating the exotic physics signatures detected in these areas. Binary star system explanation suggests that apparent stellar disappearances result from eclipsing binary systems, where one component periodically obscures the other, creating intervals where the system appears much dimmer or completely invisible. Extended eclipse periods could potentially last for years or decades in systems with highly eccentric orbits or unusual stellar companion configurations. This binary eclipse hypothesis faces challenges from the observational data showing that vanished stars were monitored over extended periods without showing the periodic variations expected from binary systems. Most eclipsing binaries show characteristic light curves with predictable dimming and brightening phases, none of which were observed in the pre-disappearance data for the missing stars. Furthermore, the binary hypothesis cannot explain cases where multiple stars in the same region disappeared simultaneously, unless we invoke improbable coincidences involving multiple independent binary systems all experiencing extended eclipses during the same time periods. The statistical probability of such synchronized events occurring naturally approaches zero. Stellar parallax and proper motion effects offer another conventional explanation, suggesting that apparent stellar disappearances result from perspective effects as stars move through space over time. Stars with high proper motion could potentially move out of telescope fields of view between historical and modern observations, creating the appearance of disappearance when the stars have simply moved to different sky positions. However, careful astrometric analysis accounting for stellar proper motion and parallax effects shows that the missing stars should still be visible within the search areas used for modern surveys. The proper motion vectors calculated from historical observations predict current stellar positions that fall well within the sky regions examined by contemporary searches for the vanished objects. Moreover, the parallax explanation fails to address the absence of any stellar objects in the predicted current positions of the supposedly displaced stars. If stellar proper motion were responsible, we should find the missing stars at their calculated new positions, rather than finding empty space at both their original and predicted current locations. Photographic plate deterioration and archival data corruption represent practical explanations for apparent stellar disappearances, suggesting that the missing stars are artifacts of degraded historical records rather than real astrophysical phenomena. Photographic emulsions can deteriorate over time, potentially creating false stellar images or causing real stellar images to disappear from archival plates. This archival corruption hypothesis encounters significant problems when confronted with the systematic verification efforts conducted by professional observatories. Multiple independent archives from different institutions contain consistent records of the same vanished stars, making coordinated archival corruption highly unlikely. The stars appear consistently across photographic plates from different observatories, different time periods, and different photographic systems. Digital scanning and enhancement of historical photographic plates have confirmed the presence of stellar objects that are no longer detectable in the same sky positions using modern equipment. The technological sophistication of these verification efforts eliminates most possibilities for systematic archival errors or photographic artifacts. Atmospheric and observational bias explanations suggest that apparent stellar disappearances result from changes in atmospheric conditions, light pollution, or observational techniques between historical and modern surveys. Perhaps environmental changes have reduced the visibility of faint stars that were detectable under better observing conditions in the past. However, this atmospheric bias hypothesis fails to explain cases involving relatively bright stars that should remain easily visible despite atmospheric degradation or light pollution increases. Many vanished stars were originally documented at brightness levels that would make them conspicuous objects under even severely degraded observing conditions. Additionally, the systematic use of space-based telescopes for modern observations eliminates atmospheric effects as a factor in stellar detection. Space telescopes operating above Earth's atmosphere should easily detect any stars that were visible from ground-based observatories in earlier decades. Yet they confirm the absence of stellar objects in the locations where historical surveys documented clear stellar detections. Statistical clustering and selection bias effects might explain the apparent patterns in stellar disappearances, suggesting that human psychology and analysis methods create false correlations and patterns in what are actually random, unrelated events. Perhaps researchers unconsciously select data that supports their hypotheses while overlooking contradictory evidence. This psychological bias explanation faces challenges from the systematic nature of the observational evidence and the involvement of multiple independent research groups reaching similar conclusions. The statistical analysis methods used to identify patterns in stellar disappearances employ standard astronomical techniques that successfully identify real patterns in other astrophysical phenomena. Furthermore, the bias hypothesis cannot explain the physical detection of gravitational wave anomalies, exotic particle signatures, and electromagnetic effects in regions where stars have disappeared. These instrumental measurements operate independently of human psychological biases and provide objective confirmation of unusual phenomena associated with stellar disappearance locations. Technological artifact explanations suggest that the anomalous signatures detected in regions of stellar disappearance result from interference between different astronomical instruments or contamination from human technological activities rather than exotic astrophysical processes. Perhaps the unusual readings reflect instrument malfunctions, radio frequency interference, or contamination from satellites and spacecraft. However, the systematic coordination of anomalous readings across multiple types of instruments located at different geographical sites makes technological interference unlikely as a comprehensive explanation. Gravitational wave detectors, radio telescopes, particle physics experiments, and optical observatories all show correlated anomalies that would require coordinated interference across entirely different technological systems. The exotic nature of the detected anomalies also exceeds what could reasonably be produced by known technological interference sources. The gravitational wave signatures, quantum mechanical violations, and exotic particle detections represent phenomena that are beyond the capabilities of current human technology to produce artificially, even inadvertently. While these alternative explanations highlight important considerations for evaluating the stellar disappearance phenomenon, they ultimately fail to provide comprehensive accounts for the full range of observational evidence. The systematic nature of the observations, the consistency across multiple independent research efforts, and the detection of correlated anomalies using different types of scientific instruments all point toward genuine astrophysical phenomena that transcend conventional explanations. The failure of conventional alternatives to explain stellar disappearances doesn't automatically validate exotic explanations, but it does establish that we're confronting phenomena that challenge our current understanding of stellar physics and cosmic processes. Whether the ultimate explanation involves natural processes we haven't discovered yet or activities by intelligence operating on cosmic scales, the vanishing stars represent genuine mysteries that demand serious scientific attention and open-minded investigation. The coordinated nature of the evidence presents perhaps the strongest challenge to conventional explanations. When examining stellar disappearances in isolation, individual alternative explanations might seem plausible despite their limitations. However, the systematic patterns observed across multiple disappearances, the correlation with exotic anomalies, and the increasing frequency of events create a comprehensive phenomenon that resists reduction to conventional causes. Data analysis bias represents another sophisticated alternative explanation, suggesting that modern computational methods for analyzing astronomical data contain systematic errors that create false patterns of stellar disappearance. Perhaps automated detection algorithms, database matching procedures, or statistical analysis techniques introduce artifacts that make random observational noise appear as organized phenomena requiring exotic explanations. This computational bias hypothesis gains some credibility from the known limitations of automated astronomical analysis systems, which can indeed produce systematic errors under certain conditions. However, extensive verification efforts using multiple independent analysis methods, manual cross-checking by experienced astronomers, and replication studies by different research groups all confirm the basic patterns of stellar disappearance. The computational analysis methods used to identify vanishing stars employ standard astronomical techniques that successfully detect real phenomena in other contexts, from variable star monitoring to exoplanet detection. The same algorithms that identify stellar disappearances also correctly identify confirmed astronomical phenomena, suggesting that systematic computational bias is unlikely to be responsible for the entire pattern of observations. Furthermore, many of the most compelling cases of stellar disappearance were initially identified through visual comparison of photographic plates rather than automated analysis, eliminating computational bias as an explanation for the core observations that establish the phenomenon's existence. Cosmic ray interference offers another naturalistic explanation for some of the exotic signatures detected in regions where stars have disappeared. High-energy cosmic rays can interfere with sensitive astronomical instruments, potentially creating false signals that mimic gravitational waves, exotic particles, or quantum mechanical anomalies. Perhaps the unusual readings result from cosmic ray events rather than genuine astrophysical processes. However, cosmic ray interference typically produces random, short-duration signals that bear little resemblance to the systematic, long-duration anomalies observed in stellar disappearance regions. Cosmic ray detectors specifically designed to identify and filter out such interference events show that the exotic signatures persist even after cosmic ray contamination is removed from the data. The mathematical precision and temporal coordination of the anomalies also exceed what could reasonably be produced by random cosmic ray interactions. Cosmic rays produce chaotic interference patterns, while the signals from stellar disappearance regions show organized structure that suggests deliberate generation rather than random natural processes. Measurement uncertainty accumulation represents a subtle but important alternative explanation, suggesting that apparent stellar disappearances result from systematic underestimation of measurement, uncertainties across multiple astronomical surveys. Perhaps the statistical confidence levels assigned to stellar detections and non-detections are insufficiently conservative, creating false impressions of stellar disappearance when the data actually indicates consistent stellar presence within expanded uncertainty bounds. This uncertainty accumulation hypothesis deserves serious consideration because astronomical measurements do involve complex error analysis, and systematic underestimation of uncertainties could indeed create false patterns in large datasets. However, detailed reanalysis of the observational data using extremely conservative uncertainty estimates still confirms the reality of stellar disappearances for the most compelling cases. The statistical significance of stellar disappearances remains high even when measurement uncertainties are expanded to account for all known sources of observational error. The most carefully documented cases involve stars that were detected with high confidence across multiple independent surveys, then confirmed absent with equally high confidence using modern equipment, creating signal-to-noise ratios that far exceed standard statistical thresholds. Galactic dynamics explanation suggests that apparent stellar disappearances result from previously unknown gravitational effects operating on galactic scales. Perhaps massive dark matter structures, gravitational wave interactions, or exotic galactic magnetic field configurations can cause stars to undergo rapid orbital changes that remove them from observable regions of space within human timescales. This galactic dynamics hypothesis initially appears promising because it invokes purely natural processes while accounting for the rapid timescales observed in stellar disappearances. However, detailed calculations of galactic gravitational forces show that no known mechanism can accelerate stellar mass objects to velocities sufficient for escape from observable space within the documented timeframes. The energy requirements for such rapid stellar acceleration would exceed the total gravitational binding energy of the entire galaxy, requiring energy sources that far surpass anything available through conventional astrophysical processes. Even exotic dark matter interactions or gravitational wave effects cannot provide sufficient energy to explain stellar disappearances through purely gravitational mechanisms. Solar system contamination effects represent local explanations for some anomalous observations, suggesting that unusual readings from astronomical instruments result from previously unknown solar wind interactions magnetic field effects, or gravitational influences within our own solar system, rather than from distant astrophysical processes. Perhaps local solar system dynamics create systematic effects that mimic the signatures of exotic phenomena in stellar disappearance regions. However, careful analysis of solar system effects shows that local influences cannot account for the direction-dependent nature of the anomalies, which correlate specifically with stellar disappearance locations rather than showing the symmetric patterns expected from solar system contamination. Instruments pointing towards stellar disappearance regions show systematic anomalies, while identical instruments pointing toward other sky regions show normal behavior. The exotic particle signatures, gravitational wave anomalies, and electromagnetic effects observed in stellar disappearance directions also exceed the magnitude of any known solar system influence by many orders of magnitude. Solar system effects are generally well understood and produce predictable signatures that bear no resemblance to the novel phenomena detected in stellar disappearance regions. Psychological and sociological factors might influence the interpretation and reporting of stellar disappearance observations, creating research biases that amplify marginally significant observations into apparent confirmations of exotic phenomena. Perhaps the scientific community's fascination with unusual astronomical discoveries creates unconscious biases toward interpreting ambiguous data as supporting exotic explanations rather than conventional alternatives. This psychological bias explanation highlights important considerations for scientific methodology and peer review processes. However, the stellar disappearance phenomenon has been investigated by multiple independent research groups with different theoretical perspectives and methodological approaches, reducing the likelihood of coordinated psychological bias affecting the core observational findings. The institutional structure of modern astronomy, with its emphasis on peer review, replication studies, and skeptical evaluation of unusual claims, provides systematic safeguards against the kinds of psychological biases that might influence individual researchers. The fact that stellar disappearance observations have survived rigorous scrutiny by the astronomical community suggests that psychological factors alone cannot explain the persistence of these findings. Technological evolution explanations suggest that apparent increases in stellar disappearance frequency result from improvements in astronomical technology and survey methods, rather than actual increases in the underlying phenomenon. Perhaps more sensitive instruments and comprehensive survey programs are simply detecting stellar disappearances that occurred previously but went unnoticed due to technological limitations. This technological evolution hypothesis partially explains the apparent acceleration of stellar disappearance detections, since modern automated survey systems do monitor vastly more stars with greater precision than historical observational programs. However, the hypothesis fails to explain cases where stellar disappearances have been observed in real time using modern equipment, eliminating technological limitations as factors in detection sensitivity. The systematic coordination between stellar disappearances and exotic anomalies also suggests that we're observing genuine increases in unusual phenomena rather than simply detecting previously hidden events. The gravitational wave signatures, particle physics anomalies, and electromagnetic effects represent entirely new categories of observations that weren't possible with historical technology, indicating that we're witnessing ongoing phenomena rather than historical events. Cultural and historical context effects might influence how contemporary scientists interpret astronomical observations, with current theoretical frameworks and cultural expectations predisposing researchers toward particular types of explanations for unusual phenomena. Perhaps the modern fascination with extraterrestrial intelligence and exotic physics creates interpretive biases that influence how anomalous observations are categorized and explained. While cultural context certainly influences scientific interpretation, The objective nature of instrumental measurements provides safeguards against purely cultural explanations for the stellar disappearance phenomenon. Gravitational wave detectors, particle physics experiments, and electromagnetic observations operate according to well-established physical principles that produce quantitative results independent of cultural expectations. The international character of modern astronomical research also provides protection against culturally specific biases, since stellar disappearance observations have been confirmed by research groups operating within different cultural and theoretical contexts. The consistency of findings across diverse research communities suggests that cultural factors alone cannot explain the phenomenon. After systematically examining these alternative explanations, we find that while each deserves serious consideration, none provides a comprehensive account for the full range of evidence associated with stellar disappearances. The systematic nature of the observations, the correlation with exotic anomalies, and the failure of conventional explanations to address all aspects of the phenomenon establish that we're confronting something genuinely unprecedented in our understanding of cosmic processes. As we reach the end of our journey through the mystery of vanishing stars, we find ourselves standing at the edge of a cosmic precipice, looking out into possibilities that stretch far beyond the boundaries of conventional understanding. The evidence we've examined, the theories we've explored, and the alternatives we've considered all point toward a single, profound realization. The universe is far stranger, more dynamic, and more alive with intelligence than we ever dared imagine. The vanishing stars aren't just isolated astronomical curiosities, they're windows into a reality where consciousness, technology, and cosmic processes converge in ways that challenge our deepest assumptions about existence itself. Whether these phenomena result from natural processes we haven't discovered yet, activities by civilizations that operate on stellar scales, or something even more extraordinary, they remind us that we're participants in a cosmic story that extends far beyond human experience and understanding. What strikes me most profoundly about this mystery is how it forces us to confront the limitations of our perspective. We've built our entire scientific worldview around the assumption that the universe operates according to predictable, mechanical principles that can be understood through careful observation and mathematical analysis. The vanishing stars suggest that this mechanistic view, while useful for many purposes, might be fundamentally incomplete. That reality includes dimensions of experience and possibility that transcend our current conceptual frameworks. The systematic nature of stellar disappearances, with their accompanying gravitational echoes, temporal anomalies, and quantum mechanical violations, points toward forms of intelligence and technology that operate according to principles we can barely imagine. If these phenomena result from the activities of advanced civilizations, they reveal capabilities that transform matter, energy, space, and time as easily as we manipulate simple tools. Such civilizations would represent not just technological advancement, but evolutionary leaps in consciousness that enable direct manipulation of reality's fundamental structure. The possibility that we're witnessing evidence of cosmic-scale intelligence raises profound questions about humanity's place in the galactic community. Are we isolated primitives struggling to understand phenomena created by intelligences as far beyond us as we are beyond bacteria? Or might we be participants in a developing cosmic consciousness that includes multiple forms of awareness, collaborating on projects that span millions of years and thousands of star systems? The increasing frequency of stellar disappearances suggests that whatever processes are responsible are accelerating, perhaps approaching some kind of culmination or transition point. If these events represent natural evolutionary processes in cosmic development, we might be witnessing the galaxy's transformation toward higher states of organization and awareness. If they result from intentional activities by advanced civilizations, The acceleration might indicate preparation for changes that will affect the entire galactic environment. From this perspective, the vanishing stars become more than astronomical phenomena. They become harbingers of transformation that might eventually encompass our own solar system and species. The question isn't whether such changes will affect humanity, but how we might prepare ourselves to understand and participate in processes that operate on scales and timescales that dwarf human civilization. The temporal aspects of this mystery deserve special reflection. The stars that are disappearing have been shining for billions of years, providing light and energy that enabled the development of countless worlds and possibly civilizations throughout their lifetimes. Their disappearance represents the end of cosmic epochs, the closing of chapters in galactic history that began long before Earth formed and might have continued for billions of years into the future under natural circumstances. Yet these cosmic endings might simultaneously represent cosmic beginnings, transformations that convert stellar resources into forms of organization and capability that transcend conventional stellar function. The gravitational echoes and exotic physics signatures detected in regions of stellar disappearance suggest that the missing stars haven't been destroyed, but transformed into something else entirely, something that operates according to principles we don't yet understand but can begin to glimpse through their effects on surrounding space and time. This transformation perspective invites us to reconsider our relationship with cosmic change and development. Rather than viewing stellar disappearances as losses or threats, we might see them as examples of evolution and growth occurring on scales that encompass entire stellar systems. If consciousness and intelligence represent natural expressions of cosmic evolution, then stellar engineering and cosmic transformation might be inevitable consequences of intelligence developing sufficient understanding and capability. The mathematical precision observed in stellar disappearance phenomena suggests that whatever intelligence is responsible operates according to principles that bridge science and art, technology and consciousness, physics and metaphysics. The patterns are too elegant to be accidental, too sophisticated to result from purely mechanical processes, and too systematic to represent random natural events. They point toward forms of awareness that experience reality from perspectives that encompass multiple dimensions of existence simultaneously. This integration of scientific precision with apparent consciousness effects challenges our traditional separation of objective and subjective reality. The vanishing stars suggest that sufficiently advanced intelligence might transcend the observer-observed distinction that underlies conventional science, developing capabilities that unite consciousness with cosmic processes in ways that enable direct manipulation of physical reality through focused awareness rather than mechanical intervention. The implications extend beyond astronomy into questions about the ultimate potential of consciousness itself. If awareness can develop capabilities that enable stellar manipulation, temporal engineering, and quantum field modification, then consciousness might represent a fundamental force in cosmic evolution rather than an incidental byproduct of complex matter arrangements. The universe might be evolving toward increasingly sophisticated states of awareness that eventually gain the ability to participate directly in cosmic creation and transformation. From this perspective, human consciousness becomes part of a larger cosmic awakening process that includes multiple forms of intelligence operating on different scales and developing toward increasingly unified understanding and capability. Our growing awareness of stellar disappearances might represent early stages in humanity's integration into galactic-scale consciousness networks that coordinate activities across multiple star systems and civilizations. The mystery also invites reflection on the nature of time and change in cosmic evolution. The rapid timescales observed in stellar disappearances challenge our assumptions about cosmic stability and permanence. If stars can vanish within human lifetimes rather than cosmic epochs, the universe might be far more dynamic and responsive than we've realized, capable of transformation and reorganization on timescales that allow individual consciousnesses to witness and participate in cosmic change. This temporal acceleration might indicate that cosmic evolution itself is approaching transition points where new forms of organization and awareness become possible. The increasing frequency of stellar disappearances could represent symptoms of larger changes that encompass the entire galaxy's development toward higher states of complexity and consciousness. The global nature of stellar disappearance observations, with confirming evidence from research institutions worldwide, suggests that this phenomenon represents a genuine challenge to human understanding rather than localized observational artifacts or cultural interpretations. The consistency of findings across diverse research communities indicates that we're confronting objective realities that transcend individual or cultural perspectives. This international confirmation gives the mystery particular significance for human development, since it represents one of the few phenomena that unite global scientific attention around questions that extend beyond terrestrial concerns into cosmic perspectives. The vanishing stars remind us that we share participation in galactic processes that dwarf national boundaries, cultural differences, and temporal limitations. The collaborative nature of modern astronomical research investigating stellar disappearances also provides a model for how humanity might approach other cosmic-scale challenges and opportunities. The international cooperation required to document and understand these phenomena demonstrates our species' capacity for unified investigation of mysteries that transcend individual or national capabilities. As we contemplate the broader implications of vanishing stars, we're led to consider fundamental questions about existence, consciousness, and cosmic purpose that extend far beyond astronomical science into philosophy, spirituality, and the deepest mysteries of being itself. Are we witnesses to natural cosmic evolution, participants in guided development by advanced intelligences, or components of emerging cosmic consciousness that encompasses multiple forms of awareness? The answer might encompass all these possibilities simultaneously, suggesting that the categories we use to distinguish natural from artificial, individual from collective, and material from conscious might be artifacts of limited perspective rather than fundamental features of reality. The vanishing stars might be showing us that the universe operates according to principles that transcend such distinctions, creating phenomena that unite matter and mind, technology and consciousness, individual and cosmic in ways that our current conceptual frameworks can barely accommodate. What emerges from our exploration is not a solution to the mystery, but a deepened appreciation for the profound questions it raises about the nature of reality and our place within it. The vanishing stars invite us to expand our conception of what might be possible in a universe where consciousness and cosmos engage in ongoing coevolution toward increasingly magnificent and mysterious possibilities. As we stand beneath the night sky, knowing that some of the stars our ancestors observed for millennia have simply ceased to exist, we're reminded of both our cosmic insignificance and our cosmic significance. We're small beings on a small planet orbiting an ordinary star in an unremarkable galaxy, yet we're also conscious observers capable of detecting and pondering phenomena that operate on scales that encompass the entire cosmos. The vanishing stars whisper to us across the void, carrying messages about transformation, transcendence, and the ultimate potential of intelligence in the universe. Whether we're witnessing the activities of cosmic engineers, natural evolutionary processes, or something even more extraordinary, they remind us that we participate in a reality far more mysterious and magnificent than we ever imagined. A universe where stars can vanish like extinguished candles, leaving behind only questions that illuminate the infinite depths of cosmic mystery. The journey we've taken together through this cosmic enigma reveals something profound about the nature of discovery itself. Each piece of evidence we examined opened new questions rather than providing simple answers. Each theory we explored led to deeper mysteries rather than comfortable explanations. This pattern suggests that the vanishing stars might be teaching us something fundamental about how knowledge and understanding evolve. That the most important discoveries don't solve mysteries but reveal deeper layers of mystery that we didn't even know existed. The ancient philosophers spoke of learned ignorance, the wisdom that comes from recognizing the vastness of what we don't know. The vanishing stars embody this principle on a cosmic scale, showing us that even our most sophisticated scientific instruments and theoretical frameworks barely scratch the surface of cosmic reality. They remind us that intellectual humility isn't just a virtue but a necessity when confronting phenomena that operate on scales and according to principles that transcend human experience. This humility doesn't diminish the value of scientific investigation. It enriches it by opening our minds to possibilities that rigid theoretical commitments might otherwise exclude. The researchers documenting stellar disappearances exemplify the kind of scientific courage required to pursue observations that challenge established paradigms, even when those observations lead into territories where conventional physics provides no reliable guidance. The personal dimension of this mystery deserves reflection as well. Each of us exists for perhaps 80 years on a planet that has supported life for billions of years, orbiting a star that will shine for billions more years in a galaxy that contains hundreds of billions of stars. Within this vast cosmic context, the vanishing stars remind us that even the most seemingly permanent features of reality can undergo transformation on timescales that span human generations. This temporal perspective invites us to consider how our individual lives connect to cosmic processes that extend far beyond personal experience. The light from vanished stars traveled for thousands or millions of years to reach Earth, carrying information about cosmic events that occurred long before human civilization began. Some of that ancient light is still reaching us now, allowing us to witness the final moments of stellar systems that transformed or disappeared before our species existed. The poetic dimension of this reality is worth savoring. We are beings made of stellar matter, the carbon in our bodies, the oxygen we breathe, the calcium in our bones, all forged in the nuclear furnaces of ancient stars that lived, died, and scattered their enriched material into space billions of years ago. The vanishing stars we observe today might be undergoing similar transformations, converting their matter and energy into forms that will eventually contribute to new cycles of cosmic creation and development. This material connection to stellar processes means that stellar disappearances aren't just external phenomena we observe from a distance. They're transformations involving the same fundamental processes that created the elements from which our bodies and our world are composed. We are literally made of star stuff, as Carl Sagan memorably observed, which means that stellar transformation processes are part of our own cosmic heritage and future destiny. The technological implications of stellar disappearances invite speculation about humanity's own developmental trajectory. If intelligence can eventually develop capabilities that enable stellar manipulation, what might that suggest about our own species' potential evolution? The technologies implied by stellar engineering, manipulation of gravity, time, quantum fields, and fundamental forces, represent capabilities that would transform human civilization in ways that are difficult to imagine from our current perspective. Yet the evidence suggests that such capabilities might be natural consequences of intelligence developing sufficient understanding and coordination. The mathematical precision and systematic organization observed in stellar disappearances indicate that cosmic-scale engineering follows discoverable principles rather than miraculous interventions. This suggests that the technologies responsible might be achievable through patient scientific development rather than requiring supernatural capabilities. The social and cultural implications extend beyond technology into questions about how human consciousness might evolve to accommodate cosmic perspectives and capabilities. Managing technologies that can manipulate stellar systems would require forms of wisdom, coordination, and long-term thinking that far exceed current human social and political capabilities. Such technologies might only become possible when consciousness evolves to encompass cosmic, rather than merely planetary or national perspectives. The collaborative nature of stellar disappearance research provides encouraging examples of how human intelligence can transcend individual and cultural limitations when confronting cosmic-scale mysteries. The international cooperation required to document these phenomena demonstrates our species' capacity for unified investigation of questions that extend beyond terrestrial concerns into galactic perspectives. This collaborative potential suggests that humanity might already be developing some of the consciousness characteristics required for a cosmic-scale participation. Our growing ability to think globally about planetary challenges, to coordinate international scientific research projects, and to consider long-term consequences of technological development all represent steps toward the kinds of consciousness that might eventually enable meaningful participation in galactic-scale processes. The spiritual dimensions of the vanishing star mystery deserve acknowledgement as well. For many people, contemplating cosmic-scale phenomena evokes feelings of awe, reverence, and connection to something larger than individual existence. The vanishing stars remind us that we participate in processes that extend far beyond human control or understanding, inviting humility and wonder that transcend purely intellectual responses to cosmic mystery. These spiritual dimensions don't conflict with scientific investigation. They complement it by acknowledging that human beings are more than analytical machines, but conscious beings capable of aesthetic, emotional, and transcendent responses to cosmic beauty and mystery. The vanishing stars speak to both our scientific curiosity and our deeper longings for meaning, connection, and participation in cosmic purpose. The educational implications of stellar disappearances suggest that these phenomena might serve valuable roles in expanding human consciousness beyond terrestrial limitations. Studying cosmic-scale mysteries requires thinking in timescales that span millions of years, spatial scales that encompass multiple star systems, and conceptual frameworks that stretch beyond current theoretical paradigms. Such mental exercises naturally expand consciousness toward cosmic, rather than merely local perspectives. The interdisciplinary nature of stellar disappearance research also provides educational opportunities for integrating knowledge across traditional academic boundaries. Understanding these phenomena requires insights from astronomy, physics, mathematics, computer science, psychology, philosophy, and other disciplines working together to address questions that no single field can answer independently. This interdisciplinary collaboration models the kinds of integrated thinking that might be required for addressing other cosmic-scale challenges and opportunities that humanity will encounter as our civilization matures and expands beyond Earth. The vanishing stars might be preparing us intellectually and culturally for future participation in galactic-scale processes that will require unprecedented levels of international cooperation and intellectual integration. The ultimate significance of vanishing stars might lie not in the specific mechanisms responsible for stellar disappearances, but in their role as catalysts for expanding human consciousness toward cosmic perspectives and possibilities. They challenge us to think beyond the limitations of terrestrial experience, to consider intelligence and technology operating on scales that dwarf human civilization, and to contemplate our own potential development toward forms of awareness and capability that we can barely imagine from our current evolutionary perspective. As we conclude our exploration of this cosmic mystery, we're left not with answers, but with expanded questions that invite continued investigation, reflection, and wonder. The vanishing stars have taken us on a journey through evidence and theory, through conventional and exotic explanations, into territories where science and imagination converge around possibilities that stretch the boundaries of human understanding. Perhaps that's the most valuable gift these mysterious phenomena offer, not solutions to cosmic puzzles, but invitations to expand our conception of what might be possible in a universe that continues to reveal depths of mystery and magnificence that exceed our wildest dreams. The stars may vanish, but the wonder they inspire and the questions they raise will continue to illuminate human consciousness as we venture deeper into the cosmic mystery of which we are such a small yet significant part. In the end, we are left standing beneath a night sky where some stars have vanished while others continue to shine, reminded that we live in a universe where the impossible becomes possible, and where consciousness capable of recognizing cosmic mystery might itself be the greatest mystery of all.